So for lesson 10, we're going to talk about special right triangles. And the first thing we need to do is identify what type of triangle we have. So in this one, because we see the two congruency marks, we know we're 45, 45, 90. So our two legs are the same. So we know our other leg is 4, and then the rule is from leg to hypotenuse, we multiply by the square root of 2. So our hypotenuse is 4 square root 2. Obviously, this is a 30, 60, 90. They gave us the hypotenuse. So the rule is to get from the hypotenuse to the smallest side, we divide by 2. So 10 divided by 2 is 5. And then to get from the smallest to the medium side, we're going to multiply it by the square root of 3. So those are the easy ones. They get a little more challenging. So here, 45, 45, 90. You see the congruency marks. So the rule is you take the hypotenuse and you divide by the square root of 2. Well, we have to rationalize, so square root 2 on the top, square root 2 on the bottom, and that gives us 17 square root 2 over 2 for each of them. And nothing simplifies, so we have to stay right there. Same thing here, they give us the middle side. So to get to the smaller side, we have to divide by the square root of 3, which forces us to rationalize. No big deal. And we end up with 5 square root 3 over 3. We double that to get to the hypotenuse, and we get 10 square root 3 over 3 as our hypotenuse side. We go to the fifth one. Given an equilateral triangle with sides of length 9, find the length of the altitude using special right triangles, and then confirm it with Pythagorean theorem. So, if we are going to have an equilateral triangle, what that does for us is, when we drop the altitude of an equilateral triangle, what that creates, since all the angles are 60, that creates a 30, 60, 90 right triangle. So we know the hypotenuse is going to be 9. So to get the shortest side, it's 9 over 2, which you could leave as 4.5 if you'd like. It doesn't say exact. And then that gives us 9 radical 3 over 2 for the altitude, because you take your smallest side and you multiply it by radical 3. So if we wanted to do that in our Pythagorean theorem, so we're a squared plus b squared equals c squared, we end up with 9 over 2 squared plus 9 radical 3 over 2 squared equals 9 squared. And since we're just checking, realistically, you can plug that whole left side into your calculator, and what you end up getting is you get that 81 equals 81. So that checks out. So therefore, our special right triangle rules worked, and there's our homework for our special rights.